gonna show you a few lava formations, starting with Pele's hair. Pele is the Hawaiian goddess of the volcanoes. This is her hair. In nature, this forms when lava falls over edges and cliffs and stretches out. Lava bombs are very good at producing them because they're very efficient at stretching the lava out. And then these thinner filaments rapidly cool down and darken in color, but also remain quite flexible, so it definitely looks a lot like hair. In Iceland, this is not a very common lava formation, but some volcanoes in the world produce Pele's hairs all the time. Now the lava has slowly reached the bottom of the slide. Can you feel the heat? So the colder air in the room quickly solidifies the lava. Here you see, it's not moving anymore. The outer layer is now solidifying, but also protecting the inner lava from the outer air. So even though here it's not moving, there is liquid lava flowing in a lava tunnel and still slowly coming out at the bottom. And it will continue to do that for a few more minutes. Here comes a chunk of ice on the front of the lava flow to show you the interaction between the two a bit more. The water is rolling off of the hot surface of the lava as fast as it can, and you can see that the steam from the ice is getting under the lava flow and it wants to get up and out and escape, but the solidifying lava is not allowing that. That's how that big bubble is inflating. Don't worry, it's not going to pop with pieces flying away. If the steam finds a way out, which it just did, it will just slowly sink away and collapse a bit. But this is more or less how it's going to stay. Now the whole lava flow is very quickly solidifying. The outer edges have already become solid enough that I can lift the whole lava flow. You see, one big piece. And the liquid lava that's hiding inside is going to escape. That's all the light and the heat coming from down below. We have a nickname for this lava. This we call mozzarella cheesy lava. For obvious reasons. That's not an official term, but in my opinion it should be pretty descriptive. And you can see when the lava cools and turns black, it becomes a bit fragile. It actually turns into a glass, a volcanic glass. It's called techilite. Techilite has 40% silica. That's not much. Normal glass has 70. And the material that lacks a certain amount of silica becomes fragile when it cools. So, the more our lava cools, the more it's gonna break. It has started doing that on its own. Now that it's cooling, the lava is shrinking, taking up less space than it did when it was hot, and that creates many fractures in the lava flow. That's the crackling sounds that you can hear. It's the lava that has already started breaking up as it is shrinking and cooling down. Now let's have a closer look at the glass in the front. This glass is very delicate, very thin as you can see, but inside of the bubble, that's where the lava is still most orange and hot. So even the thin layer of lava is insulating and traps heat. You see a bit of paper ignites instantly. And in nature, those big open hollow spaces get very big and they are very efficient at trapping heat. Those open cavities can be hot for many, many years, even after eruptions stop. And that's why it's dangerous to walk on a young lava flow. You never really know where those lava caves are, and if they are close to the surface of a lava flow, their ceilings are very thin. We don't see them from above, but our weight can be plenty to fracture them. I always look forward to this part of the show, not gonna lie. Now the whole front is very quickly solidifying as well. We can already have a peek underneath the lava flow. And there, we will see the lava is still very orange and glowing, and there's little lava rain droplets falling down. The sand, the pulverized lava that's in the slide, is very insulating and good at trapping heat. The bottom part of the lava flow will take much longer to cool down than the top. And the little things you see falling, this is the sand that was in the slide before the liquid hot lava came, and it got remelted by the hot lava flowing over it. That's how hot the lava is. It remelted the sand that it flowed over. Now in nature, a big lava flow can easily take 100 years or 2 to fully cool down. Lava cools very slowly. Our lava flow is microscopic in size compared to what you can see in nature, but we've tried it one time. We left the lava flow just to see how long it would take to cool down on its own. 5 days later, it was still very hot. So even our tiny little lava flow cools very slowly, and we cannot wait for the material to cool and then do the next show. So after each show, we come into the room and we take the lava out, even though it's very hot. And we're able to do that thanks to this. Low heat conductive steel tools. It's only with tools like this that we will indirectly manipulate the lava. And we do that by tapping the lava. The colder it is, the easier it's going to be to break into smaller pieces. Those we can then scoop out. It will go into a steel bucket. Bucket is on a trolley, and all of that we push and roll to the back without ever directly touching the lava. And in the back, we will reuse this lava for a future show. This will be one of tomorrow's shows. We recycle lava. This is very experienced lava. It has done this trick many times before, and it will do it many times more. And you see, we still have the ice lying right next to the lava flow. Bit surprising that it's not melting faster. I feel like we are melting faster than the ice right now. Well, there is a reason why the ice isn't melting fast. This is the reason. Sand is non-conductive of heat. I can easily touch the sand right next to the lava flow, even under it. Because heat does not travel through the sand is still completely cold to the touch, as if the lava was never next to it. But out of the sand and above the heat waves again, the ice will melt just as fast as before, because the lava is still very hot. And I will tell you exactly how hot the lava is now after a few minutes of cooling with a heat gun. And I will first tell you how hot the coldest lava is. This piece that was on the rod at the beginning and that has been isolated for a few minutes already, that should be the coldest lava. 280 Celsius, 530 Fahrenheit. But if we look for some orange lava, that should be the hottest lava. For example, inside of this bubble. There, we still have 670 Celsius, 1230 Fahrenheit. So you see some parts of the lava flow are still very hot. We could probably do a nice barbecue with these temperatures. Okay, I'm not gonna lie, we can. I know because we did a few times. For scientific purposes, of course. And here in Iceland, when we have a lava tourist eruption and we can go visit, we bring a backpack with water, clothes, maybe our cameras, a nice sandwich for lunch, and always marshmallows, sausages, and we cook it directly on the hot natural lava. Is it smart? No, because there's heavy metals in the lava that is not healthy to digest. But it's worth an Icelandic tradition. And it's